nuages très haut dans le ciel, il annonce les changements de temps.
En dessous, il y a des nuages plus denses comme les altocumulus qui ressemblaient à des moutons et les astrostatunes en hiver.
En dessous de 2000 mètres, on parlait de nuages bas. Les stratus, par exemple, qui c'est un nuage très bas, risqué et qui peut donner de la brume et la pluie très fine.
Le nimbostratus, c'est un nuage assez bas dans le ciel de couleur gris foncé. Il donne de la pluie et de la neige. Tous ces nuages se développent verticalement, mais il y en a aussi qui se développent horizontalement.
C'est le cas de cumulus et cumulonimbus. Les cumulus sont gros et dévêtus, et les cumulonimbus peuvent se développer sur plus de 10 000 mètres d'eau, et donnent des orages, de la pluie, de la grêle, tornades, etc.
Pourquoi les nuages ne tombent pas? Les nuages sont formés par particules d'eau ou cristaux de glace trop petites pour ser affectés par la force de la gravité. Donc, nous pouvons dire que notre hypothèse est vraie. Les microgoulettes ont une vitesse de chata tellement fiable qu'ils sont portés par l'air.
C'est seulement quand elles grandissent qu'elles réussissent à tomber et finissent comme plus sur le sol. Les certaines turbulences qu'il y a dans l'atmosphère, les nuages qui flottent.
Et notre conclusion finale, c'est que les nuages ne tombent pas parce qu'ils sont dans un système atmosphérique dynamique qui les maintient en altitude.
Le moindre courant d'air chaud fera d'abord stationner le nuage avant de le faire remonter. Par contre, un courant d'air froid soumettra moins de résistance et après, il fera monter le nuage. Lorsqu'il pleut, ces fines gouttelettes d'eau se regroupent pour former une plus grosse goutte d'eau qui ne peut pas être tenue par l'air, alors elle tombe jusqu'au sol.
Nous avons trouvé ces informations sur Wikipédia, ScienceFair, YouTube, plusieurs sites et on parlait de la météo.
Les futures recherches. Combien pèse un nuage? Pourquoi les nuages sont blancs? Pourquoi les nuages changent de couleur?
Avez-vous des questions à nous poser?
Nous avons préparé aussi un petit jeu pour vous inviter à reconnaître les différents types de nuages. Si vous voulez participer, on vous attend ici.
Merci à tous de votre attention. On espère que ça vous a plu et on se retrouve bientôt sur un nouveau vidéo de C'est pas sorcier.
Ça a été très intéressant ce que vous avez fait, ce que vous avez préparé. Et c'est bien clair que vous avez étudié et vous avez bien compris aussi le cycle de l'eau. Oui, c'est très important d'économiser et de ne pas gaspiller l'eau. Vous le savez bien, oui. C'est bien. Merci pour tout. Allez, merci. Les tombez pas. Et les avions. Ah, les avions. Ah oui. Oui. Les avions, pourquoi ne tombent pas? Allez.
Cuando queramos.
Hello, I am Amaima. I am a scientist. I investigate global warming for the United Nations organization.
Hello, I am Ines. I am an ecologist activist from Greenpeace.
Hello, I am Juan. I am a polar bear. My natural habitat, the Arctic sea ice, is endangered due to climate change.
Hello, I am Mario. I'm a negationist. I support President Trump.
The reason why scientists are concerned is that Earth's global climate is changing. The planet is warming up faster than any time in the past.
So then, what is making Earth's climate warmer? Scientists have discovered that this is related to carbon dioxide emissions.
I don't believe in global warming. This winter we have had a lot of snow and rain in countries such as Spain. In fact, the climate is cooling, not warming.
I live in the Arctic zone, and I am losing my natural habitat because ice caps are melting because the human enhanced greenhouse effect.
The greenhouse effect is good for all living things. It's a natural process in the atmosphere.
It is not that simple. Global climate is changing and we need to do something about this.
Can you show me any evidence of this? I bet you can't.
Of course we can, and we are going to show you our research. We are going to convince you that global warming is a real issue.
So, the important question is, how does CO2 affect temperature?
We have different hypotheses about this. CO2 increases Earth's temperature, CO2 decreases Earth's temperature, CO2 doesn't change Earth's temperature.
What materials are you using in this experiment?
We need bicarbonate and vinegar to produce carbon dioxide, a lamp to produce heat and light, 2 glass jars and 2 thermometers to control temperature.
How do you conduct your investigation?
First, we leave jar 1 empty. But in jar number 2, we mix vinegar and bicarbonate to produce carbon dioxide. Then we close both jars tightly and make sure the carbon dioxide remains inside. Next, we turn on the lamp to produce heat and light that simulates the sun. After, we observe and record temperatures for about 15 minutes.
What do you observe during this investigation?
As we can see, temperature in jar 2 is higher up to minutes 5 and 6. After this, both jars maintain a similar temperature. In minute 10, we switch off the lamp and we wait for temperature to cool down. It's very clear how jar 2, which contains CO2, cools down more slowly than jar 1.
What are your conclusions of this research?
Definitely, we can conclude that the amount of CO2 not only increases temperature, but also traps heat and makes temperature in the glass jar cool down more slowly. In order to find some evidence, we researched on IMH website. This is the organization that studies weather in Spain. We have found how CO2 have increased in the last 60 years in Spain, and how the temperatures have increased in Egea too.
As we mentioned before, global warming is related to the greenhouse effect. Let me explain how the greenhouse effect works. The heat from the sun is trapped by gases on the atmosphere, such as CO2, because Earth's atmosphere works like a greenhouse that keeps Earth warm enough for life.
Humans are using energy in enormous quantities. For example, car engine and power plants makes energy in a chemical reaction called combustion by burning fossil fuels like coal, gas, and oil. These are called carbon dioxide emissions.
These carbon dioxide emissions going to the atmosphere increase the greenhouse effects due to human actions. This is called the human-enhanced greenhouse effects. As a result, more of the sun's heat gets trapped in the atmosphere and the planet warms up. And this is having terrible consequences for the planet, such as heat waves, heavy precipitation, the sea level is rising, habitats are being destroyed, ocean acidification, and an increasing number of wildfires.
Dear friends, thank you very much of your investigation. I changed my mind. Now I understand how important it is we do something to stop global warming, as it is having terrible consequences on the planet. I'm not a negationist anymore. I'm going to join Greenpeace to save the planet.
And what do you think? What our friends and families can do to stop global warming and save the planet?
We are all responsible to reduce carbon emissions by choosing a cleaner and more efficient way to use energy at home or in school. Turn off the light, reduce the amount of water we use, planting trees to absorb carbon dioxide, and recycling and reducing the waste we produce.
Let's stop global warming. Let's make the earth smile again.
Thank you very much for the presentation. That was wonderful. What would you do at home to actually save the planet? One of the measures you take to save our planet. Yeah, something you do at home, for example.
At home, we can do a lot of tips to save planets. For example, switch off the light to not produce a lot of electricity. We can plant trees also in our gardens or in our balconies to absorb carbon dioxide we produce. And also, instead of having long baths, we can have short showers to reduce the amount of water we use.
Thank you very much. I'm convinced too.
¿Cuándo empiezo?
Yeah. Hello, we are the year 6 students of Los Alvarez School. We are going to present an experiment, which is, what is the best soil to grow a potato? We choose this experiment because we have a school garden and we are interested to know what is the best soil to grow a potato.
First, we started an investigation about growing garlics on the faces of the moon, but we watered them alone and they die. So we have to start a new investigation.
At the beginning, we predict 18 to 3 persons that the best soil will be the humiferous soil. To do this experiment, we need 6 containers, 6 different types of soil like rocky soil, sandy soil, clay soil, limestone soil, humiferous soil, and silty soil. Then 6 potatoes and water.
The first thing that we had to do was plan the fair test. To do this, we have to make sure everything, the same types of soil, the same quantity of water, the same quantity of soil, the same temperature, the same sunlight, and the same type of potatoes.
When we have planned the test, we have to do it. First, we take the containers and we put soil inside at the same level. Then we put 1 potato in each at the same level. After, put the same quantity of water in each container. Every 2 days, we take photos and we water it 215 milliliters of water for each plant. This is what happened. This is a table that shows how the results of the experiment. We measured how much grow the plant. As you can see, the humiferous soil is the best for plants and potato. The best soil for plants and potato is the humiferous, and our prediction was right.
Thank you very much, and thank you very much for all.
Have you any question?
Yeah, just one question for you. Are you planting now potatoes in your school garden? Are you planting now potatoes in your school garden?
No. Yes. The humiferous soil.
Yes, we can find in the school.
Thank you. Thank you, guys.
Good morning, everyone. We are Candela and Olivia, and we are going to talk about magnetism and magnetic fields.
The other day in the school, our teacher was explaining how a compass works, and she said,
The Earth is a giant magnet,
Oh, impressive.
and it has a magnetic field surrounding it.
Wait, what? I can't see anything.
That is because it's invisible.
Then I thought, how can we see magnetic fields? Let's go to the lab. I remember that someone told me that the mosses grow in the north part of the earth, and maybe has something to do with the magnetic field and help us see it.
Oh, don't be fooled. It must be something inside the earth that would help us. And such as plastic comes from oil, and oil comes from inside the earth, maybe it has something to do with the magnetic field. And
If we want to check if the magnetic field works with these three materials, we need a magnet like this one. First, we're going to check with a piece of wood. If the wood stays stuck, we will know that the magnetic field is interacting with the wood. Oh no, it doesn't work.
Your hypothesis is wrong.
it's my turn now. Let's see what happens if we do the same with a piece of plastic. Oh no, I was wrong.
Your hypothesis was wrong too.
Let's see if we try with iron.
It worked!
Okay, so now we know that iron is the only material that is affected by the magnetic field. But how can that help us see it? Maybe if we use small pieces of iron, it can show us the magnetic field.
I don't think so. I think it's going to be impossible to see it because the iron will be stuck in the magnet.
Now we are going to check with these two materials, but now with small pieces.
Let's try with plastic. Okay, it's not working.
Let's try with wood. Okay, it's not working.
Let's try with iron powder. Incredible! I can see the magnetic field.
Yes, but remember that the teacher told us that magnetic fields are in 3D, and this one is flat. So if we want to see it in 3D, we need to use a ferrofluid like this one. A ferrofluid is a magnetic liquid, and we can build one mixing vegetable oil and iron. The process could take a while. That's why we have here this one. Let's see what happens if we put a magnet under the ferrofluid.
As you can see, there's spikes where the magnet is. Look, it seems to be alive.
Now we know that the correct hypothesis was that the iron powder helped us see the magnetic field.
In conclusion, magnetic fields can be seen if we use iron powder or ferrofluid. Thank you for your attention. We hope you like it.
¿Alguna pregunta?
¿Cuánto tiempo lo habéis dejado macerar? How long did you mix the oil with the iron?
We bought on internet.
Ah, ¿lo compraste eso ya?
Sí.
Vale, vale.
¿Qué materiales son?
¿Es aceite vegetal?
Aceite vegetal con...
Pero que lo compraron hecho, será como que se macera y se descompone. Un poco disgusting. Enhorabuena, ¿eh?
Congratulations.
Hello, we are Carlota, Hugo,
Carla,
and Paula. We are from Alcañiz and we came from Palmireno School. This is our experiment.
Stop bananas!
Our school is part of a fruit program, and we observed that bananas are the favorite fruit which comes to our school. If bananas come too green or yellow, it's no problem. But if bananas arrive too brown, most of the students don't want to eat them. So we wonder how it would be possible to store bananas to keep them yellow and tasty.
Our investigation is called How Should We Store Bananas to Keep Them at Their Best?
Wait, what do you mean, at their best?
Well, we did a questionnaire of all the boys and girls in our school to find out how they prefer to eat their bananas. And the results were that most children prefer to eat their bananas plain yellow. So here, at the best means yellow.
Our hypothesis was that bananas would be best stored in a plastic bag out of the fridge because the plastic bag would prevent the oxidation. Also, we thought that bananas would be the worst option to take in the water.
We did some research. What are the health benefits of bananas? Bananas are an excellent source of potassium and vitamin B6, fiber and carbohydrate, and supply some vitamin C. Bananas help to lower cholesterol and blood pressure, keep our heart and bowels healthy, and have a high fiber content. The inside of a banana skin can be used to calm an itchy mosquito bite.
On with the experiment. For this experiment, we needed 2 plastic bags, 2 boxes, a fridge, 2 pieces of newspaper, 2 pieces of cloth, 2 pieces of foil, 2 Tupperware boxes, and some bananas.
The steps that we follow were label each banana with a red or blue sticker. Red for room temperature and blue for the fridge. Rubber place each banana into each storage, in a box, in a newspaper, in cloth, in a Tupperware with water, and place them into the fridge. Repeat this step with the bananas with the red sticker. Check the progression of the bananas, taking photos every 2 days by the harness.
We made specific observations during and after the 9-day experiment. Here are the results of our findings related to storage and color change.
Our conclusion is that our hypothesis was incorrect because the best banana for color was inside the water, but it was inedible. Also, the best banana for hardness was in foil inside the fridge, so our final conclusion is that the best to keep is in foil.
Having completed the results related for color and firmness, we decided it was also necessary to evaluate the most important factor, the taste. How should our stored bananas taste after 9 days? Here are the results. Our experiment for taste confirms that bananas kept in foil in the fridge best taste.
We finally wanted to check. Is true that bananas which are brown are sweeter? Using iodine as a testing solution, which is able to signal the presence of starch, like this. We place iodine into each of our bananas, plus 1 green and 1 yellow banana. The results prove that as a banana matures, the starch turns to sugar. The iodine highlights the starch turning black. In the sweeter, more mature banana, there is no hardly or any black. And here you have some photos of our experiment.
In the future, we would also like to investigate the different bananas in the banana family or the different fruits. And thanks to the university to let us come to this school to make this great project. Thanks. Do you have any questions?
Very good job. Well, you talk about temperature and also the oxidation, but did you check the influence of the humidity, the water?
No, but it's a thing that we will improve in the future.
More questions? Thanks.
Espera, que falta
Hello, and today we are going to be presenting a Titanic project. The Titanic, sink or float? My name is Keisha and I represent a working woman traveling in 3rd class. Many of us died in the sinking of the Titanic.
My name is Alberto and I represent a working class man traveling in the Titanic. Most of us died in the tragedy.
Hello, my name is Dalio. I represent a high-class gentleman who travels in 1st class. Half of us survived.
Hello, and my name is Lucas, and I represent the captain of the ship. I stayed on the boat until the end, so I went down with it.
There are many theories about what happened to the Titanic. In this project, we would study the conditions in which it sank. The Titanic was a British liner, the largest at that moment, which sank the 15th of April of 1912 in its first voyage from England to New York. It was considered one of the safest ships because it had 16 compartments that could be closed with watertight doors. If a compartment had a leak, the doors could close. But on the night of the 15th of April of 1912, an iceberg hit it. 5 compartments were flooded, and there were only lifeboats for 1,178 people.
And learning about the history of the Titanic, we asked ourselves, what changed in the Titanic to make it sink? So then we made an investigation on all aspects of floatability. The first question was, what makes a boat float? We found that there are some key concepts to take into account: weight, mass, density, volume, buoyancy, and the displacement of water. 2 forces are acting on an object when being placed on water: weight and buoyancy. Weight is the downward force made by earth attracting the boat, and buoyancy is the upward force made by liquid on the boat. To understand buoyancy, we need to understand the displacement of water. When an object is being placed in water, it displaces an amount of water, and that amount of water depends on the volume of the object. So then, the buoyant force is equivalent to the amount of water that it displaces. In other words, there is a downward force that depends on mass, and an upward force that depends on volume. So then, we could also say that as density is the relation between mass and volume, we could also say objects that are less dense than water will float, but if they are higher, they will sink.
With all this information, we built a hypothesis. The Titanic changed its weight, and that is why it sank. To prove it, we made an experiment. And to do the experiment, we needed the following materials: 3 containers, 3 bottles, 1 marker, a scale, and stones. First, we built 3 Titanics. 1 bottle representing the Titanic before the accident didn't have water. Another bottle representing the Titanic after the accident had 1/3 of the water. And the 3rd Titanic, representing the Titanic when it sank, was full of water. As a second step, we measured the displacement of water. To do this, we put the bottle inside the container and we observed how much water went up according to the marked lines. That is 1.5 liters. And then, to calculate the buoyant force, we weighed it. That is 1.5 kilograms. Later, we measured the weight of each Titanic with the help of a scale. As a 5th step, we calculate the density of our Titanic, dividing the weight by its volume. And finally, we compare the density of our Titanic with the density of the water.
As you can see in the graphic, the weight has increased in all the Titanics. In the Titanic before the accident, it was 500 grams. In the Titanic after the accident, it was
1,200 grams. And the Titanic, when it sank, it was 1,850 grams. The displacement of water was the same in all the Titanics because the volume was the same. Also, the buoyancy was the same. It's obviously. The density has increased in all the Titanics. In the Titanic before the accident, it was around 300 kilograms per cubic meters and is lower than the density of the water. That's why it can float. In the Titanic after the accident, it was 800 kilograms per cubic meters and is lower than the density of the water. That's why it can float. But the Titanic, when it sank, the density increased a lot and was bigger than the density of the water. That's why it can't float. In conclusion, the element that made the Titanic sink was the density of the Titanic, caused by an increase of the weight. Thanks for listening to us.
Ya está encendido.
And
Good morning, everyone. We are Carmen, Angela, Javi, and me, Lucas. We are coming from Joaquin Costa School, Raus, and we would like to explain our experiment about the acid rain. The title of our experiment is The Effects of Acid Rain on Plants' Growth. As you can see in this poster, we have divided the information into the following parts. How did we come up with this idea? How we design it, hypothesis, experiment, graph and charts, conclusion, and so on. If you have any question, we would be happy to answer them at the end of the presentation. I hope you enjoyed. Now Carmen is going to explain how did we come up with this idea. Thank you.
Hi, as Lucas said, I am going to explain you how we came up with this idea. This year we have been learning about acid rain in natural science. We learned what it is, how it is produced, and also its main effect for the environment. Once we finished all these theoretical aspects of that unit, we wanted to know how acid rain could affect us, people from Graus, in our everyday life. So, we brainstormed the consequences of the acid rain in different areas. And we were interested in investigating its impact on plants' growth. We wanted to experience this environmental problem with our own eyes and measure its effects on local plants. Now Angela is going to explain you the hypothesis and how we designed our experiment.
first of all, we asked our families which local plants usually grown in our village in terms of soil and weather conditions, and they told us to choose tomato and green bean. They also told us both plants grow fast, so we could analyze the impact in a few weeks. Another recommendation from the Council of Wise People was related to when to water the plants and where to place them. Tomatoes must be watered every day and beans every 2 days, and all the plants must be located in a warm and sunny place to have sunlight. After that, we decided the materials we needed to carry out the experiment. These are 2 seed beds, tomato and green bean seeds, 4 different types of soil, orchard soil, river, holm oak tree, and soil bag. Also, we use pH paper used to measure materials for acidity and a pH meter. We use 1 bottle of vinegar, 4 different types of water. We mixed tap water with vinegar and we got the pH we wanted, showed as follows. pH around 4, labeled in orange. pH around 5, labeled in pink. pH around 6, labeled in green. And pH 8, ground tap water, labeled in blue. We use 4 manual irrigation sprinklers, orange, pink, green, and blue. Flexible rulers and worksheets for data collection. So our hypothesis is, if we water a plant with acid rain, it grows less than usual or even dies. Now Javi is going to explain the experiment itself.
First of all, I'm going to explain what is acid rain and how it can affect the environment. After that, we will see the steps we have followed to carry out this experiment. Acid rain is rainfall that has been acidified. That is, it has a pH lower than 7. This means that has a lot of protons, what can produce some chemical reactions. This can cause the loss of nutrients of different plants. Nowadays, the main cause of acid rains comes from gases released by industry and transportation, because when it gets in contact with rain, it gets acid. Acid rain can damage crops, ecosystems, monuments, buildings, etc. Because when it falls, it reacts with a certain types of soil. Now, I'm going to mention the main steps of this experiment. As you can see, we use a color code to recognize the type of water and type of soil of each group of plant. Orange, pink, green, and blue. Then we filled in the 2 seed beds the 4 selected soils. We select these 4 because we want to analyze what happens when they get in contact with acid rain and because they are easily found in our village. Here, there is a simple draw to better understand the experiment. First, nutrients are in the soil. Plants need nutrients. Acid rain falls and reacts with nutrients while soil adds or subtracts the acid rain, and depending on the soil and its components, the plant don't grow and nutrients may disappear. In the next step, we plant the green beans and the tomatoes. We decided to water them the first week with ground tap water. And when they were already sprout, we decided to water them with a different pH. Then we established the criteria, and we decided to measure the total length of the plant. To do that, we use a flexible ruler. And all this data were recorded on these charts. After 3 weeks, we conclude the observation stage, and we start to analyze all this data. So now Carmen is going to explain the results of the experiment through the following charts.
Once we finish all this process of watering and measuring the plants, we analyze all the data collected and we make the following graphs in order to show the results in a more visual way. Here you can see 8 different charts, 4 to show the evolution of the tomato seeds and 4 to show the evolution of the green bean seeds. These graphs represent the total height of both tomato and green bean plants in the first stage of plants growth. Here you can see the centimeters, and here the dates of data collection. Let's have a look to the height of the tomato plants. The results can be divided into 2 parts. The best 2 types of soil, according to the Council of Wise People, that are the bag and the hallmark tree soil, and the type of soil that you can find it normally in grounds, that are the orchard and the river soil. In the best 2 types of soil, we can see that the acid pH has the worst results, and the best pH for them is the pH 6. This is normal because it is the pH normally found it in the rivers and in the rain. However, in the soil found in grouse, the acid pH is better for plant growth. And with this experiment, we don't know why. We should make another experiment to understand these chemical reactions. The results from the green bean plants are more general and don't depend so much on the type of growth, of the type of soil. Usually, the acid pH affects negatively for growth. And it seems logical. We can see this surprising result, that is that grouse tap water maybe is not really good for grouse plants and for us. Now Lucas is going to talk about the conclusion and possible experiments to be done in the future.
We can say that our hypothesis is true. Is not true, because as Carmen has explained, it depends on the type of soil and the type of plant. In this phase of growth plant, we can say that our hypothesis is true for green beans, but not for tomatoes. As you can state, this experiment has been done only in the first stage of a plant life cycle. So future research will be the extension of this investigation along the rest of the states. Another possibility can be the analysis of the impact of acid rain in our monuments and buildings. Maybe the next ScienceFair, who knows? This is the end of our presentation. Thank you very much for your attention. Have you got any question?
I don't know much about grouse area, so I have a question because you said you were interested in knowing the effect of the acid rain in grouse. Do you have any problem with acid rain in grouse? Any fabrics, any hydroelectrical central something? Or why did you think of acid rain? What made you think of the problem of the acid rain in grouse? No? Why did you think of acid rain and could be a problem for grouse? Do you know the origin of the acid rain? Why there are there? No?
Because we study in naturals the acid rain, and we were interested in this problem. No, in grouse we don't have fabrics, and yes.
We are Alejandra,
Iris,
Mar, and Aleix. The title of our experiment is, does it rust? Fresh water versus salty water and boiled water with oil.
We realize that metal objects around us are getting rusted, and we don't know why. That's the reason why we have
prepare this experiment. We ask ourselves, in which water does steel rust faster? In salty water or in fresh water? What if we boiled water and add oil? So we researched about this topic and we learned that oxidation is a chemical reaction. When steel and iron react with water or air, it forms a chemical called rust. Rust has a reddish color, formed on iron and steel as a result of a chemical reaction of iron and oxygen at the presence of water or air.
Thank you for the information, Iris. Now we are going to explain you the hypothesis. The hypothesis is that in salty water, steel objects will rust faster because when it rains, water comes from the sea. Also, we thought that in boiled water with oil, nails will not rust because boil make that water has less oxygen. Besides, oil make like a lap, and that makes that oxygen cannot enter to water.
Now we are going to explain the experiment. The materials needed are plastic cups, water, salt, bobby pins, safety pins or paper clips, nails, tacks, boiled water with oil, and a test tube.
The steps we followed were, first, we took 8 cups of plastic and we add in 4 an S for salty water and in the other 4 an F for fresh water. Second, we add the water, fresh water to the F cups and an S for and salty water to the S ones. Then we observed it during 7 days and we wrote in a journal our observations. Finally, we wrote a data and a conclusion.
These photos show the observation day by day. These ones are related with fresh water versus salty water, and these ones are related with boiled water with oil.
After observing our experiment every day, we have summarized the information in these graphs. In salty water, the bobby pin oxidized the day 3, the paper clip the day 2, the nail the day 6, and the tag the first day. In fresh water, the bobby pin the day 4, the nail the day 6, and the tag and the paper clip the day 6. Boiled water with oil, it haven't oxidated because oil makes like a tap.
After analyzing this graph, we have the results. The result is the most rusted objects were the tag, the paper clip, and the bobby pins. All of them were more rusted in salty water than in fresh water. The nails in fresh water and in salt water didn't rust it, but they lost the bright color that was the galvanized layer. The nails weren't rusted in boiled water with oil.
As a conclusion, we can say that our hypothesis was correct because all items rust faster in salty water than in fresh water, because salt is more corrosive and this speeds up the process. We were also right when we tried with boiled water with oil, because the items do not rust, because the water is boiled and has less oxygen, and the oil works like a lid and it do not let oxygen pass through the water. Alice, can you explain us what is galvanized?
Yes, of course. Galvanized is a layer made of thick that covers steel objects to avoid faster oxidation.
To finish, we wanted to apply to real life what we have learned. If you want to protect your bike or car from rust, you shouldn't leave it outside because in there are particles made of water that start the process. Also, if you want to protect your bike or car, you can make them of stainless steel or galvanize these objects. We also think that the hand tools we have at home, we can protect them with a thin layer of oil to avoid oxygen enter through it. This is what we have learned. We hope you learned something new today. Thanks for your attention.
What's the point of using boiled water with the oil and not fresh water with the oil?
because boiled water has less oxygen and metals need oxygen and water for rust.